midterm report. And we are finishing off today addition and subtraction formula. We're going to start the next section. We'll see how far we get in that one, where we look at what are called double and half angle formulas. I'm 99% sure that we won't get that finished, but that's fine. Let's focus on what we should get finished. So question 8 is asking us to prove an identity. So this type of question pops in and out all over the place. The first one is prove that the cosine of x plus pi upon 3 add the sine of x take away pi upon 6 is always equal to 0. Seems unlikely.
Is that pi upon 6 or pi upon 3?
Pi upon 6.
Okay.
Yeah. So even different angles. And allegedly, and we're going to prove it, that that is equal to 0. So what I'm going to do is I am going to take this guy is A and this guy is B. So isn't that essentially the cosine of A plus B? Great. So let's write down what the general formula of the cosine of A plus B is. It's the cosine of A, cosine of B, take away the sine of A, sine of B, right? And this guy, I'm going to call it A and B again. So this is going to be the sine of A take away B. And the sine of A take away B is going to be the sine of A cosine of B take away the sine of B cosine of A. Now all these A's and B's are going to turn into these guys depending on which question we're dealing with. So in this case, it's going to be the cosine of x times the cosine of pi upon 3, take away the sine of x times the sine pi upon 3. And in this case, it's going to be the sine of x times the cosine of pi upon 6, take away the sine of x times the cosine of pi upon 6. A little bit hesitant here because I want to make sure I've got all the pieces in place. Right, the cosine of that fella. Well, the cosine of pi upon 3, which is this guy, is a half.
So shouldn't be, I'm sorry.
Yeah, no, if I've made a mistake, tell me.
Yeah, I
What
think
is it?
I see it where sine of B should be sine of pi over 6.
Thank you. You're right. Right, sine of that guy, right? Cosine of that guy. So cosine x times a half, then I have a sine of x times a sine of pi upon 3. And if I find pi upon 3, it's here, sine of pi upon 3. And it's going to be what, root 3 over 2. And then I have the sine of x times the cosine of pi upon 6. There's pi upon 6, and the cosine of pi upon 6 is root 3 over 2. Take away the sine of pi upon 6 is a half with a cosine of x. And that is good news. Doesn't that half cosine get killed off by that? And doesn't this fella here get killed off by this fella right next to him? And so the entire answer is exactly what it should be. Haven't we proved that the left-hand side is in fact 0? So think of identities as they're telling you what it simplifies down to. Your job is to get to that point, right? If they say it's equal to sine x, then your job is to show that the left-hand side eventually becomes sine x. I'm glad you caught that, because if you didn't have caught that for me, wouldn't I actually not get the answer to work because it wouldn't have matched up? Any questions about that? Are we okay? Okay, next one, there's only 3 of these guys, but they get progressively uglier to prove. How about this one for scary? Prove the identity that this ugly fraction that I'm writing down right now the whole ugly thing ends up being the tan of y. Wow. If you looked at that, I wouldn't in a million years thought that that ugly thing is actually going to simplify to the tan of y. So that's going to be pretty impressive, right? If we get this to work. These are called A's and B's, but can't I just think of the A being an X and the B being a Y, right? So I won't write down all my codes, I'll jump right into it. So this sine of X plus Y becomes the sine of X cosine of Y plus sine of Y cosine of X. Take away, so I'll put brackets around that. Take away the sine of X minus Y. So that's going to be sine of X cosine of Y, take away sine of Y cosine of X. And then cosine of X add Y is going to become cosine X cosine Y, take away sine X sine Y, subtract. In this case, you're going to get cosine of X cosine of Y plus sine X sine of Y. Why am I sticking brackets around these two expressions? Why didn't I just, write minus and write it all down? What's the significance of this inside brackets? Because I'm doing it for a good reason. It's to emphasize that you're subtracting all of this. If I just removed the brackets, wouldn't I only be subtracting the first thing and not the second?
Shouldn't
So it's just
the bottom be a addition?
Thank you. Yes. Right. Let's keep moving. And I'll try and do this with the least amount of lines of working. Would you agree that that sine X cosine Y gets killed off by that guy? Would you agree? Wouldn't this sine X, this sine Y cosine X, take away that one, basically be this guy plus another one of himself? So the top line becomes 2 sine Y cosine X. Are we comfortable with what I just did there and why it worked out? Okay, look at the bottom terms. Tell me who gets killed.
The sine X sine Y.
Great. And would you agree this guy plus himself gives you 2 of them? And who do we get? We get 2 cosine X's, cosine Y's. Now that looks nice. Is there anything that you can cancel in this fraction then?
The 2 and cosine X.
And that leaves me with the sine of Y over the cosine of Y. Do you recognize the sine of Y over the cosine of Y? Isn't that exactly what it needed to be? We have proved it. You see how it worked? Isn't that amazing how something as ugly looking as that ends up being so pretty? Right? Nice tiny little tan line. Right. Our last question is not an identity. We're being asked to find the exact value of the sine of theta plus phi. So put that up here. That guy is the Greek letter theta, and this guy is the Greek letter phi, which I pronounce like, phi, phi, fo, fum, phi. I know everybody's seen theta. Has anybody seen phi anytime? Is it a new letter of the alphabet, Greek letter for you? Right. We're being asked to find the exact value of this guy. Now, they do give us some information, which is important. Let's see what they tell you. Well, you're told that the sine of theta is 4/5 and that theta is in quadrant 1. And you're told that the cosine of phi is -2 root 5 over 5, and phi is in quadrant 2. So we're being asked to find what the sine of this angle plus that angle would be, right? An exact value. We don't want nothing 0.123s, right? Exact value. And you're told this piece of information about angle theta and this other piece of information about the angle phi. And somehow or other, all of that is going to come together and we're going to get, well, whatever the answer happens to be. So I'm going to start off with this fella. If I call this guy A and I call this B, isn't this a sine of A plus B? Great. A plus B. And the sine of A plus B is the sine of A cosine of B plus the sine of B cosine of A. And in this particular case, since A is going to be theta, it's a sine of theta cosine of phi plus the sine of phi cosine of theta. So far, so good. Now, if I can find what these four things are equal to as numbers, right? Won't I have the answer? Well, if you look, what did they tell me? They tell me the sine of theta is 4/5. So isn't this guy 4/5? And they tell me that the cosine of phi is this fella. So the cosine of phi gets me that one. That's great. We have a problem. I don't know the sine of phi and I don't know the cosine of theta, but I need to know what they are, right? I need to know what kind of fractions they are, because once I've done that, we're finished. So I'm going to do a little side issue here. We've done this before. If you are told that the sine is this and that theta is in the first quadrant, then you can build a little right angle triangle, call this angle theta, call this the opposite, the adjacent, and the hypotenuse. Right. According to SOHCAHTOA, what is the sine of an angle? What's the formula for the sine of an angle according to SOHCAHTOA?
Opposite over hypotenuse.
Great. And since the top is the opposite, doesn't that make this fella 4? And since the hypotenuse is here, doesn't that make this guy 5? Do you see how I'm creating the numbers for this triangle? Now, there's only one guy missing, isn't there? The adjacent. How would I find adjacent?
4 squared plus b squared equals 5 squared.
Right, and can you trust me that it ends up being 3 when you're finished? Right. Now, what do I want for angle theta? Oh, I need to find the cosine of theta. Well, according to Pythagoras, isn't the cosine the adjacent of the hypotenuse? And the adjacent is 3 and the hypotenuse is 5. So guess what? I now have that guy. Are you comfortable about how I found the cosine of theta was 3/5? Are we good? Right. Now, I need to know what the sine of phi is. So I'm going to write down what I know about it. I know that the cosine of phi is -2 root 5 over 5. And I know that phi is in the second quadrant. So I'm going to build another nondescript right angle triangle. I'm going to make this angle phi. I'm going to call it opposite. I'm going to call this guy adjacent. And I'm going to call this third side hypotenuse. And according to SOHCAHTOA, isn't the cosine the adjacent of the hypotenuse? Okay. Now be careful about the sign right now. The adjacent is 2 root 5. The hypotenuse is 5. So I now need to find out what the opposite is. So I'm going to do c squared is a squared plus b squared. 5 squared is 2 root 5 squared plus b squared. 25 equals 20 plus b squared. 5 is b squared. So b, after a lot of hard work, is the square root of 5. And now I'm going to do a deliberate mistake. Oh, I know how this works. I need to find out what the sine of phi is. And that is going to be opposite over hypotenuse. And I've just realized that my deliberate mistake cannot be done. But I'm still going to do it. Square root of 5 over 5. Great. And now with my deliberate mistake, I'm going to make it negative. And maybe my mind was thinking, well, if this was negative, that probably means all the answers are negative. Why is this not negative root 5 over 5? Why is it positive root 5 over 5? How do I know it's positive?
Because it's in the second quadrant.
Because
Yeah.
it's in the second quadrant.
You nailed it. Now, do you know this guy over here? Shouldn't I have checked that it was actually positive 3/5? Because it could be negative, couldn't it, if it was a different quadrant? But since it was in the first quadrant, isn't it obviously positive? So I didn't worry about it, right? But in this one here, it was worth checking. So we have now got root 5 over 5. You still with me? Right. Now, not a lot I can do, but I can multiply these together and get negative 8 root 5 over 25. And I can multiply these two together and get 3 root 5 over 25. Since they share a common denominator, I can combine these, right, essentially adding them, and get negative 5 root 5. And then a little cancel. There's our answer. Actually, it's quite a pretty answer, isn't it? Are we comfortable about the entire process? Because I'm going to be doing one in a moment, and I'll leave most of the working up here. Because this guy. So here goes. I'm going to tell you that the tan of theta is a half, and that theta was in the third quadrant. And we're going to tell you that the cosine of phi is negative 5/13, and that phi is in the second quadrant. And I want you to find for me the exact value of the cosine of theta take away phi. And I'll write that bit down for you, because that's going to disappear in a second. So cosine theta cosine phi plus sine theta sine of phi. Right, that's a good question. So I'm going to give you 5 minutes to do it. See if you can finish it in 5 minutes. You got about a minute to go. Okay, we're coming to the end. Hopefully you can catch up if you didn't quite get there. So what we're trying to do is see how many of these values that we've got. Really, you don't have very much to work with right now. You don't know what that guy is. You do know that this guy is -5/13ths, and you don't know either of those two guys yet. So I'll go over here and I'll start with the tan of theta is 1/2, which we know is opposite over adjacent. So that generates a right angle triangle where there's opposite, adjacent, and hypotenuse. And so we have a 1 and a 2, and that ends up being the square root of 5. And I need to find the cosine of theta, which is adjacent over hypotenuse. So 2/√5. And I also need to find the sine of theta. And that's opposite over hypotenuse, and that's 1/√5. And then I'll take the second piece of information that we were given. And where is it? Oh, we were told, here we are. We were told that the cosine of phi is -5/13. Oh, I almost forgot. Theta is in the third quadrant, isn't it? What's the cosine in the third quadrant, positive or negative?
Negative.
Right, so that should have been a negative. What's the sine in the third quadrant?
Negative.
Negative. So these two guys are both negatives. Glad I caught myself. Now this fella here is going to be adjacent over hypotenuse. And so there's my opposite, there's my adjacent, there's my hypotenuse. And I have an adjacent of 5, a hypotenuse of 13, and that ends up being 12 after you do Pythagoras. But in this case, I only need to find the sine. And the sine is going to be opposite over hypotenuse. In this case, it's going to be 12/13ths. And it is in the second quadrant, right? And because it's the second quadrant, isn't this positive? So this one is positive. So we have 12/13ths. And here we go then. If you multiply the top together, you get +10/13√5. If you multiply these together, you get -12/13√5. They share a common denominator. And so it ends up being -2. And then rationalizing the denominator I get -2 root 5 over 13 times 5, which is 65. And well done if you got that. So using these addition and subtraction formulas, we can solve identities and we can find exact values of, things like this. So we're now moving on to section 7.3. At least we'll get a start on it. Section 7.3 will not be in this week's homework, but I will leave the homework there, so if you want to get a head start on it so you have less work next week, feel free. We're going to look at just one part of it. There's a lot of things, but we're only going to look at double angles. Well, the sine of 2a is 2 sine A cosine A. So there's a formula for finding the sine of twice an angle. It's 2 times the sine of the single angle times the cosine of its single. The cosine of 2a, that's a little bit trickier. It has 3 different formulas. It's equal to that. It's equal to that. And it's equal to that. So you might say, well, which formula do I use? I guess it depends on what you're told. Can you imagine a question where they tell you nothing but the cosines? Wouldn't it be easier to use this formula? If I only knew the sine of A, I would use this formula. If I knew the sine and the cosine, I might use this formula, right? So it depends on what you're told, which one of these 3 formulas are the most important or the most relevant. And the last one is the tan of the double angle. And this is 2 times the tan of A over 1 take away tan squared of A. And in case you're thinking these formulas are just pulled out of a hat, out of nowhere, you can actually get them. See if you make A and B the same number, right? A plus A, that's 2A, right? And you replace all these B's with A's, you'll get that guy. If you take the tan of A, right? So tan of A plus tan of A, 2 of them. 1 take away the tan of A, tan squared. So do you see that these 3 formulas just come from here? All you do is you make A and B the same letter, right? You call both of them A. And tidy it up, and you got this guy. So far, so good. So that's the guys we're going to be using for what's left of today. So let's show you the kind of question, or let's do the kind of question that you might be asked. Suppose I tell you that the sine of A is 3x, and I want you to find the exact value of the sine of 2a, the cosine of 2a, and the tangent of 2a. And I tell you that A is in the second quadrant. That's going to be important for pluses and minuses, right? A is in the second quadrant. First thing I'm going to do is build my right angle triangle. And this time the angle is going to be called A. And this side is opposite. This side is adjacent. And this side is hypotenuse. So we're going to use these triangle things again. Now, what do I know? Well, isn't the sine opposite over hypotenuse? So 3 over 8. So far, so good. And if I use Pythagoras, I end up getting the, what do I get? I get 64, take away 9. I get the square root of 55. Okay, let me pause. Are you happy that if someone tells you this, that you can create that triangle? Are you comfortable about how we do it now? Right. Sine, opposite over hypotenuse. The top thing is the opposite, the bottom's a hypotenuse, build your triangle. Okay. Now, I should be able to find the sine of A, which is obviously 3/8, the cosine of A, and the tangent of A. And I'm going to find them separately, and then I'll use the formula. The cosine of A is adjacent over hypotenuse. The tangent is the opposite over the adjacent. But since I know the angle is in the second quadrant, won't the cosine be negative and so will the tangent? So you notice how those two guys are negative. That makes sense? Right. Now, we've got all the building blocks. It's really just a matter of using the formula. So to get the sine of 2A, it's 2 times the sine of A, cosine of A. And that's going to be 2 times 3/8 times negative square root of 55 over 8. And that's not pretty, but it's negative 6 square root of 55 over 64. I can cancel down a little bit and get negative 3 square root of 55 over 32. Any problems with that? Are you comfortable with how I did it? Right. Once you know these three guys, can't you just plug and chug and make it look pretty? Now there are 2 more guys, cosine. So the cosine of the double angle could be this formula, this one, or this. Any preference? Which one do you want me to use? Any particular one you want to see being used?
The
First,
second one.
second one. Okay, so we're going to do a 2 cos squared A take away 1 version. That works. So it's going to be 2 times the square root, which is this ugly guy, squared, take away 1. And if you square a negative, you get a positive, so you get 55 over 64, take away 1. And that's 110 64ths, take away 1. Probably do it in the calculator, it's quicker and simpler. So I will go 110 divided by 64, subtract 1. And then I'll do math fraction button, and it's 23/32. And we now have the cosine of 2A. Are we comfortable with that one? Right. Third one is always going to be the ugliest. The tan just tends to be ugly, you can't help it. The tangent of 2A then is going to be 2 tans over 1 minus tan squared. So 2 tangents over 1 take away a tangent squared. Well, it's going to be 2 times negative 3 over the square root of 55 over 1 take away negative 3 over the square root of 55 all squared. And we have to try and make this as pretty as possible. And don't expect great things. But I'll do the best I can. It's going to be negative 6 over the square root of 55. If you take this thing and you square it, you get 1 take away 9/55. Are you comfortable with that? 3 get positive 9 on the top, square root times itself, 55 in the bottom. This guy I'm going to put into the calculator. 1 take away 9/55 turned into a fraction. You now have negative 6 over the square root of 55, and on the bottom 46 55s. And for emphasis, I'll put little brackets around it. You might want to say, oh, can I just leave it like that? No, we got to make this prettier, right? Style points. I've got a top guy, I got a bottom guy. You can think of this as top guy divided by the bottom. So fractions
Well,
can be thought of.
Don't you
Question.
first want to put like square root of 55 in the numerator?
Oh, over here, you like fix this one?
Yeah.
That'll work perfectly fine. I'm just not doing that way, but what you said will work perfectly fine. So it's okay to do that. I'm just going to take this one and divide it. Oops. Divide it by this one. And then I'm going to take this guy and multiply it by its reciprocal. Then I can do is kind of, well, that can get divided and get me 23. So I'm going to get negative 165 over 23 square root of 55s. It's living up to its reputation of being ugly. Agreed? Now, you mentioned, I think it was Aidan, let's see if I can remember. Was it Aidan? Who was it that went and suggested?
Putting the square root 55 in the numerator?
Yeah,
Yeah,
so,
that was me.
right. So why don't we do this one? It's kind of the same thing, but just doing it later. Now, if I do that, this tangent of 2a ends up being negative 165, the square root of 55, all over 23 times 55. Can anybody see any cancelling that we might be able to do here? That says 23 times 55, that says 165. Can you see any cancelling here?
Combine 23 and 55.
Well, you could do that and then let the calculator figure it out, and
Yeah.
that would work. But how about divide those guys and get 3? So what am I left with? Negative 3 square root of 55 over 23. And you do not want to do too many tangents for pretty obvious reasons. Are we comfortable with that process, even if the tan one took a page and a half? Any questions? Okay. Let's do an example from the homework. Yeah, we've got plenty of time. Keep that one handy. Let's find, I think there's, is it 4 questions that are like this? My memory's not perfect, but I think there are. So I'm going in right now. Okay, this one is similar to question 1. We're being asked to find the sine of 2x, the cosine of 2x, and the tangent of 2x. So instead of calling it a, they're calling it x's this time. Next time they'll probably call it theta. We're told that the tangent of x is negative 1/3, and the x is in the 4th quadrant. Okay. So I'm going to build my right angle triangle. Call that angle x. And for a tangent, it's opposite over adjacent. So it's going to be opposite. It's going to be adjacent. And this side is the hypotenuse. And we know that the opposite is 1 and the adjacent is 3. So the hypotenuse ends up being the square root of 10. That means then that we can have the sine of x, we can have the cosine of x, and we can have the tangent of x. And the sine of x is going to be opposite over that, guys. So it's 1 over root 10. The cosine is going to be 3 over root 10. And the tangent we already know is a third. And then I check what's happening in the fourth quadrant. Well, we already know that's negative. In the fourth quadrant, what is a cosine? Positive or negative?
Positive.
Positive. And can I tell you that the sine is negative? So 2 of them are negative and 1 is positive, which is pretty typical. So I don't really want to do all 3. They take too long, and I want to do another kind of question under situation. So which one of those 3 do you want me to do?
None of them.
I got that, but we have to pick one. So which one are we going for?
The first one.
Okay, so we'll do a sine of 2x. That's actually one of the nicer ones. So it's just 2 sine x cosine x. So in this case, it's going to be 2 times that ugly guy times that ugly guy, and 2 times that gives me a negative 6 over 10. Oh, isn't that a very nice answer? Right. If you're going to get nice answers, they almost always come from the sine of 2x and the cosine of 2x. And if you want a really, really ugly answer, it'll come from the tan of 2x. I mean, that's kind of the way it is. So the next situation that I wanted to show you is still in that same vein. So you're going to be asked to find all of these. But this is the thing that we haven't kind of looked at for a while. It's in the second quadrant, right? I'm telling you, or you're being told the secant is negative 4, and you're being asked to find sine of 2x, cosine of 2x, and finally tan of 2x. And all you're being given to start with is that the secant is negative 4. But I need to build my right angle triangle, because that's how we do these questions. And so while I'm getting set up, I'll say this is going to be the opposite. This is going to be the adjacent. And this guy is going to be the hypotenuse. And I can build this triangle as long as you tell me sine of x, cosine of x, or tan x, right? I can do that pretty easily. But if you tell me the secant x, I have to do a little bit more work. If you tell me the secant, I can figure out what the cosine will be. Right? What fraction will the cosine of x be if its secant is negative 4? No clue.
Negative 1/4.
I'm basically using the reciprocal property, right? That a secant and secant and a cosine are inverses or reciprocals of each other, right? Which means that I can now say that the adjacent is 1 and the hypotenuse is 4. So the adjacent, my colors here, 1, and the hypotenuse is 4. And this guy ends up being, eventually, the square root of 15. And I'm only going to take it to this point, where we can write down what the sine, the cosine, and the tangent are. And the sine is opposite over hypotenuse. And so that makes it square root of 15 over 4. The cosine is the adjacent of the hypotenuse, which makes it 1 over 4. And the tangent is the opposite over the adjacent. And that makes it essentially the square root of 15 over 1, which I'll just call square root of 15. And now I have to figure out who's plus and who's minus. X is in the second quadrant. Okay, is the sign of x going to be positive or negative if x is in the second quadrant?
Positive.
Okay. I don't need to worry about the cosine. They already told us that one, right? Is the tangent going to be positive or negative in the second quadrant?
Negative.
Negative. So I'm only going to pick one of these things. I think I'll pick the tan because that's the ugly one. So the tan of 2x is 2 tan x over 1 take away tan squared of x. And it's 2 times negative root 15 over 1 take away negative root 15 squared. So that's negative 2 square root of 15. Oh, wait a minute. Isn't that guy just 15? Good. So 1 take away 15, that's not that bad. Negative 2 root 15, negative 14. Cancel, 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 cancel. You get root 15 over 7. That one actually wasn't an ugly one at all. Wasn't that one actually quite lucky? It was not too bad. I don't have time, nor will I give you one. But if I gave you a question like these, do you feel comfortable about how you would approach them? How you'd get the sine, cosine, or tangent of the double angle? So let's do an identity. Sine x plus, oops, I almost forgot right there. Sine x plus cosine x all over cosine of 2x is equal to this fraction. And we're being asked to prove this identity. So I'm taking this side and I'm going to turn the cosine of 2x into something using sines and cosines. So can you imagine it could be cos squared take away sine squared? It could be 2 cos squareds, or it could be 1 take away 2 sine squares, right? We have 3 versions.
We just choose the first one.
I would agree with you. So use the first one. And then you might say, well, I'm stuck. But we're not that stuck once you realize that this guy in the bottom is a difference of 2 squares. Isn't it like, you know, a squared take away b squared, right? It's a difference of 2 squares. It just happens that the first guy is a cos squared and the second guy is a sine squared. That means I can actually factor it as a cos plus a sine times a cosine. Take away a sine. Do you see anything going on here? Is there anything on the top that might cancel with something on the bottom? If I put a little bracket around it, does that help?
Sines and cosine.
That guy
Or-
is that what you mean? This guy cancels out this guy?
Yeah.
It does. And you are left with, hey, we proved it. That's what we're after. Any questions? Okay, make sure that you check, if you didn't hear this at the beginning, make sure that you check your email. You have, your report has been sent out, your midterm report. Roughly we're halfway through, so that gives you a good idea of how well you're doing. The solutions will not be appearing till sometime this weekend when I have time. And so you can have a look at the solutions and see what you did right or what you might have got wrong. I think it would be fair to say that most people, when they lost points, was the multiple choice. Right? You tended to do worse on multiple choice than you did in the bit that came later. So when you look at your grade, it'll tell you what section 1 is was multiple choice, and that was out of 20 points, and section 2 was out of 80. So you get an idea of how well you did. That's it. Bye-bye. Make sure you put your name down, last name, before you go for attendance. Check for accuracy. I'll see you later. If you have a question, hang about and I'll try and solve it.
Will we have a test this weekend?
Yeah, you will.
Okay, just on 7.1 and 7.2?
Exactly.
Okay.
So that'll be a nice, hopefully a nice short test.
Yeah, I hope so. Have a good one.
You too.
I had a quick question about the one we just did.
Mm-hmm.
I was confused how you got cosine x plus sine x is equal to that bottom.
Have we got from here to here?
Yeah.
Okay. So if I went and said to you, a squared, oops, start again. If I went and said to you, a squared take away b squared, do you recognize what's called a difference of two squares? In other words, you can factor it. You seen that? You might have seen it with numbers like x squared minus 49. Yeah. Okay. And that's called the difference of two squares. So if you ever get something squared take away something else squared, it falls into this category of a difference of two squares.
Okay.
So what I did is I said cosine x plus sine x, that's this bit. Cosine x take away sine x, which is this bit. And that's what we got. There.
Okay. I'm just used to seeing it with numbers and x.
Yeah.
Instead.
Yeah. Well, that's how you typically do see them, right? You typically, one of those guys at least is a number.
Yeah. Okay. Thanks.
You're welcome. Jason, you got a question for me?
Yeah, I had a question about problem 3 on the 7.2 homework.
Okay, let me go find it. 7.2 addition subtraction question number. You said 3, I believe.
Yeah.
Right. So we are looking at. Well, mine might be different from yours. So you tell me what yours is. I have the tan of -195. What you got?
Yeah, mine is the tan of -195. So
Okay, you got lucky, right?
that would be the same thing as the tangent of 165, right?
Yes.
So we did that problem, I think, in class, and
Did we split it as a 120 and a 45?
no.
I mean, there are other splits, but we could have split it that way.
Yeah,
right?
we could have split it that way.
How did you split it? Let's stick to your split then.
Let's see. 135 and 30.
Okay, that works too. And so that becomes the tan of 135 plus the tan of 30. And 1 take away the tan of 135, tan of 30. Are you comfortable with that?
Yeah.
Okay, so I'll get my unit circle out and try and find all of these, because the chances are it's just a mistake in, writing down the wrong numbers. Right. So if you go to 135, which is this angle going this way, y divided by x gets me -1. If I do the tan of 30, which is this one, y divided by x ends up eventually becoming that, because the 2's cancel. Then you have 1 take away. The tan of 35 is -1, and this guy is 1/√3. So it looks like I'm going to have -1 plus 1/√3, and on the bottom, 1 plus 1/√3. Did you get something that looks like that?
Yeah, I think so.
Okay, so I'm going to make it look pretty by multiplying by the special version of 1/√3. So what that gets me is it gets me -√3 plus 1 on the top, and it gets me positive root 3 plus 1 on the other side, and that's the answer.
Okay. Yes. Okay, so negative. Okay, so when we did it before in class, the answer that you ended up with was -3 plus the square root of 3 over 3 plus the square root of 3. So
I don't know what I did. I can't remember.
okay.
Did it work for the one that you just typed in?
No, so this was the third, so it reset. The
Okay.
answer that it said was correct, was the square root of 3 minus 2.
Okay, so let's show you what they did there. This guy is the same thing. I know it doesn't look like it, but I wouldn't expect you to know how to do this. That's WebAssign being a pain. I'm going to multiply by a special version of 1, which is called the conjugate, which is basically this guy, but with a minus. And so when you multiply these two together and these two together, when you multiply these two together, you get that. You check out. If you FOIL these guys, you get -3 plus the square root of 3 plus another square root of 3, take away 1. And so you get -4 plus 2 square root of 3's over 2, and that becomes -2 plus the square root of 3, and that's the answer that they got, and that's why they got what they got. Actually, I think they wrote it this way around, but it's the same thing. So this answer is correct. This is just a prettier looking version of this answer.